Good evening, everyone. I, Utkarsh Gaurav, on behalf of Industry Interaction Cell, welcome you all to Industry Expert Session by Verizon. Today, we have Ganesh Siddhamali to share his knowledge on machine learning operations, end-to-end ML pipelines. Ganesh Siddhamali is a Verizon veteran for almost 21 years, worked across data, business intelligence, and data science, and finally settled as an associate director for AI industrialization and ML engineering. He worked for Deloitte Consulting before Verizon for 2 years. His experience in IT field dates since 1996 to the present. Among all his responsibilities, one of his primary tasks is developing a comprehensive AI strategy that focuses on delivering outstanding outcomes in business operations, customer services, and research analytics. Furthermore, he led a team of skilled employees for data cleaning, data preparation, data analytics, and AI model training, providing a strong technical support and driving technological innovations across Verizon's various departments. I welcome you, sir. The floor is yours.
Thank you, Utkarsh. Um, thanks again. Thanks, IIT, for giving me this opportunity. And welcome, guys. Good that it is not a Friday, it's a Thursday evening. Let me see if I'm able to kind of teach you guys, or at least go over a session on what I have in mind and what I have learned over the past 5 to 6 years that I have been there as associate director for ML engineering, and the journey I took. And whatever that I'm going to talk about here is uh, some of my own personal experience, and I'm not going to touch on any of the Verizon topics here. Just want to be clear. But again, for sure, it's going to help everyone that is attending. As he started with, I mean, the whole topic over here is about machine learning operations end-to-end pipeline. We want to make sure that we understand what Mlops is really, because everyone would think, okay, if there is data and if there is model, that is good enough, and then we will get the results what we are looking for. But we want to touch base on what is missing today and what are some of the drawbacks because of that, and what are the challenges that we are facing that we have to go and choose the path of MLOps. This is one interesting diagram for sure. I think everyone would have seen this. So this is from the paper Hidden Technical Depth in Machine Learning Systems. I think the point over here is you can see the ML. Sorry, guys. So you can see the ML code over here, which is just only a subset of the whole thing that is happening, the overall ML development, right? So you have so many processes that is happening today in order to complete a ML application, when I say, right? So you have data verification, you have feature engineering that you have to do, you have model training, you have model scoring, and then you have validation that you need to do, you have model monitoring. There are so many things that are happening, but the code part is only fraction of it. That's the whole idea. Only a small fraction of the real world ML system is composed of ML code, as shown by the small black box in the middle. The required surrounding infrastructure is vast and complex. And that is also one of the reasons, if you look at when you compare a data science and a ML engineering forum out, there is more concentration toward ML engineering rather than data science now, because they want ML engineers are considered as a full stack ML developer, where they would also know data science and also know data engineering and also some of the ML platform related activities. Going to the next slide, I think it's very clear. We know that AI system is really code plus data, right? Which is the code means over here, it is your Python code that that writes the model, that writes the algorithm, that writes even the script that cleans the data or whatever it is. And then you have the data part, which is the data that is coming into the code, right? If you want to go out and compare it to a meal, right? So most of the thing that you would need is to make sure that you're getting the better ingredient in order to prepare a final meal. And if you don't have that preparation done clearly, then you would not get the 20% that you are doing at the end. Same thing would happen for training a model. You need to have a very good source of data. You need to have a very good process in place that kind of formulates the data, cooks the data, cleans the data, and then when the data is finished, validating that and making sure that there is no data drift. There are so many things that are happening, and what we have to do is have that also taken care, and then only you train a model. So I would say maybe all the companies have matured today, but most of the people are concentrating on the 20% of the side, which is nothing but training a model, but 80% of things are not getting taken care, because of which we end up not able to kind of bring the model time to market, or kind of go to the next level of churning out models at will in 24 hours gap. So almost every company just want to talk about the maturity, right? Almost every company wants to be a data plus AI company, but the majority are new to machine learning. At least this is like 1 year back data. Either the companies would have only data, and some companies would have data and also ML models together. But when they have ML models, they would not have a very good process. So they have to end up having the model put to production in a manual way. And then there are companies which have all the three of it and also follow an automated way to productionize those ML models. I think the success of ML application in all of these areas comes to the way how they would have built the MLOps process. Now, I think this is also a known metrics where 60 to 80% of the ML models do not reach production because they don't have a very good ML process that is there in place. Okay, so now let us look at what really is MLOps and why do we need to do it, and some of the benefits. At least these are some of the benefits for sure every company would talk about. And if you just go over any article on MLOps, this is what you would see, and it's for sure that we would be able to get all of these benefits following the MLOps process. Just to read out, what is MLOps? It stands for machine learning operations. It's a core function of machine learning engineering, which is just focused on streamlining the process of taking models to production and then making sure that it is maintained there, making sure that the performance of the model is good, the stability of the model is good, and then monitoring them on a daily basis or weekly basis or monthly basis based on how good it is scored. And then finally, there are also cases where there is very good collaboration that is happening, right? Because when we say model development today, where we are in a world of maturity level 0, which is like disconnected, then the data scientists would have their model code that is there in either Git or some notebook or something. And then the ML engineers or the data engineers would not be connected to it. And there is DevOps engineers who would not know what is happening. Kind of connecting all of these people together is what the main role of MLOps is. And why MLOps? It is a useful approach for creation and quality of machine learning and AI solutions. By adopting this, we would make sure the data scientists and ML engineers are really collaborating, and they are able to increase the pace of model development and production. And by implementing CI/CD practices, it would help in doing very good monitoring, validation, and also governance of ML models. So what you're going to see in benefits is also the same. The primary benefits is across 3 areas. One is efficiency, one is scalability, and one is risk reduction. When we say efficiency, we have to make sure that we have a process in place. That way the data scientists are able to deliver very efficient models that can be put to production. And when we say efficient, there should be also a very good deployment process in place, and that is also taken care by MLOps. Scalability. It enables vast scalability and management where thousands of models can be overseen, controlled, managed, and monitored, right? This is like running a factory, right? The whole industrialization concept came in a factory because they were able to deliver 1 car, 2 cars. And then when everything started good and everyone started purchasing, they need to make sure the business that they were doing is running like a factory, where You are churning out cars and cars every other day, 100 to 200 cars. And when we have to do that, there should be process line in place. There should be automation in place. And that's the only way you can go and scale. Same thing is applicable for models also. You need to have process in place. You need to have deployment strategy in place. You need to have infrastructure in place if you want to scale your model development and deployment, right? So think about this, what would happen? You're developing a model and you know that it is all disconnected. Data science is developing it. Data engineering team is giving the data. Platform team is deploying the model and they're all disconnected. There is no process that is connecting these people together. And you're having an output, which is good output. I'm not saying there is a problem in the output. And you're showing that to the business saying, hey, use this model so that you'll be able to go out and give better decisions for your customers. And the business is coming out and saying, hey, I see that there is a very good response based on your model's score, but I want to make this change because there is a business change that has happened. And if you ask that, this is good, but I want to target it for a 24 hours release. And if these guys don't have a process in place and they have to go through all the loops and holes, then automatically what would happen? They would not be able to solve what the business is looking for, and automatically they would not be able to get the model on time, and that's where the scalability would get bad response, and you'll not be able to deploy, and the business will lose hope in the deliverables that is coming out of this whole data science and ML engineering team. Finally, responsible AI, right? There is a greater transparency and faster response to such requests, and it ensures that there is good compliance with an organization or industry's policies. This is very, very important today, because this is one area where the whole company can come to bottom if you use variables or features in your models that is really biasing towards customers and not taking data which is allowed by the customers to be seen. So all of this can be taken care only if you have control over how the process is done, how the models are built, and that's why we really need an MLOps process in place. Let me go to the next slide. Yeah, common problems. I think we came across this, but again, to just talk about it, when you look at the first window here, mundane steps with lots of boilerplate. This is the common complaint that you get from data science team saying, hey, I know I know the algorithm, I can do the model, but there are a lot of steps that you want me to do in order to productionize it. So I'm not sure how do we go about it. Next comes the part of it is slow, it is redundant, and the development is iterative. All of those are complaints that would also come from ML engineers if you're not using a very good workbench or a development workbench tool in order to develop a pipeline to deploy the models. And then finally, when it is all done, it is about handing off to production. It is all manual. When you don't have MLOps process, or if your maturity level is 0, there is no automation involved, and there is very manual process. And when there is no automation, you're dependent on a manual person who is going and deploying the model, which means you're not going to deploy the model on time. So all of these are some of the main challenges that you foresee when you don't have an ML process put in place, or when you have a maturity level of 0 in the whole ML process. Now comes the part of the main components of MLOps process, right? The scope of MLOps in machine learning projects varies depending on project's needs, but some projects require MLOps implementation for the entire data pipeline to model production, while others only need it for model deployment. But just to say, it will be always good to follow this methodology where you follow the MLOps implementation from entire data pipeline to model production, and not just do it for model deployment. Because what is happening is, if you just do it for model deployment, you don't have a process in place that will take care of what is happening to the data. Is the data coming in from the underlying systems correctly? Is the data kind of cooked properly, or the feature engineering pipeline is cooked properly for the model to take the features in order to score it on a daily basis? All of those are something that would miss, and that is the reason why we always follow it from the data pipeline to the final model production. So some of the steps, I think these are some of the steps that Sudesh would have also discussed on various steps that we look at when we are developing model, but we will also look at the same to see how we link it in the whole MLOps process. Starting with exploratory data analysis, given a problem statement, maybe look at this problem where like there is a video or maybe take Netflix as an example, and there are so many customers that are there in the base, and there is a churn problem for Netflix where they want to identify what is happening to their accounts, and everyone are going and kind of churning out, right? So first you would start ending up doing an exploratory data analysis of what is happening to customers, who are those customers who are churning out. You put all the data together, arrive at a cluster, look at common signals that you are identifying it, and then you would see, okay, are there common signals, are there causation and everything, and then you identify based on that, saying, okay, I feel like I'm able to get signals from who are churning. Now let me go out and prepare the data preparation and then the feature engineering that would go as an f of x value in order to calculate the y. And then you would go with model training and tuning. You will decide on what models to choose. So you go and train a model based on the data that you have seen. You would do a test and validation based on the data. And then finally, when it is done, this one process, model review and governance. I'm not sure if everyone follows this, but this is really, really important when you come to companies that are really getting monitored by every other governance across the world, is making sure that the model that is developed follows the process in place, make sure that the features that are used in the model are really reviewed to see that we are not discriminating against any variables that we are using to decide on what features we are using to decide the score. So all of those are done in this review. They would come back saying, hey, it is okay, you can just go out and use these variables, we are good with it. And after the sign off is where you would go out and put the model in production. And when it is done, you would have the process of model inferencing and serving, which is nothing but you put the model in place. So there is going to be input saying who would churn, who would not churn, and you go out and use that in various experience and decision making places so that you can make sure that you are having those customers stay with you. And then finally, it doesn't stop there. Model monitoring, this is very, very important, right? So now you have trained a model on a data that you have seen for the last 6 months, and there are various reasons the data might drift, either because the business logic has changed. There are so many changes that has happened to the business logic based on which you have not calculated in feature engineering, or the data is not coming correctly to the underlying tables, because of which there is data drift that are happening. And what would happen because of that? The lift that is coming in because the model would not be good, which means the marketing money that you're spending on to take care of the customers, you're going to lose. You're going to lose the marketing money because the scoring that you're getting is not right. So you would see a drift in this model score because of a data drift or a business logic change. So you need to have a very good monitoring tool in place in order to validate that and monitor that on a daily basis. I mean, today we have alerting system that would make sure that if a company has like 300 to 400 models in production, that alerting system, after every other scoring that happens on a daily basis, it would go through this model and then understand if the score is, if the performance is good for previous week based on the score, if the model is having any drift, if the data is having any drift, if the feature is having any drift, all of those are calculated properly and an alerting mechanism is set in place in order to go ahead and give it back. Now, it doesn't stop there, right? So if you feel like there is no data drift, but if you feel like there is a business logic change, there should be a trigger that should happen automatically where it automatically trains the model so that the lift gets better, right? So consider all of this working like a factory. That is what you would get out of MLOps. No human involvement here. Alerts and mechanism put in place in each and every layer that kind of informs the data science team, ML engineering team, and other teams that is interested in seeing the results. And that is what you would get out of this whole MLOps process. In the meanwhile, I'll just check the comments. Okay, fine. I think.
Currently, we do not have any. Sir.
Okay, thank you very much. Okay, now I talked about what are all the things that are happening, but I'm now again drilling down into details of the different stages of MLOps, which is really needed for us to make sure that our whole MLOps pipeline is working together, is what you're seeing here, right? So starting with development and experimentation. You iteratively try out ML algorithms and new modeling where the experiment steps are orchestrated. The output of this stage is a source code of ML pipeline steps that are then pushed to source repository. So what would happen here is, today, if you consider this as a manual process, I literally know that some of my own data scientists, they would have like several notebooks that they would have put in, where they would have different models that different model libraries that they want to try to go out and train their model in order to see which one gives a better benefit. They would have also changed various hyperparameter tuning in various notebooks that they have. And then what would happen is, I know that they, I'm talking about 1.5 years, 2 years back, they manually run it, store the data into Google Sheet or Excel sheet, compare the results and see which of the model is performing good. And then they would go out and check in that into the kit so that it goes through the pipeline. Now, there are so many tools that are available today, like MLflow. Every other Amazon has its own experiment tracking. Domino has its own experiment tracking. Data Robot has its experiment tracking. SageMaker, Azure ML Lab has its own experiment tracking. So what would happen here? You can just go out and link the Git and then say that this is a change to the code. Please have this run for different changes of code, and then it will fire up a cluster and then go out and run the model and then give the output. It will also compare all of this output and say which particular model code is giving a better result, right? So from moving from maturity 0 to maturity 3, where it is all interconnected together, where when you're running it in an overall pipeline, this automatically runs, experimentation is getting better, and it will pick the model which is giving the better score and then automatically goes and deploys that. That is what would happen in the development and experimentation stage. Pipeline continuous integration. The code that is checked in is what is packaged as executables and artifacts, right? Today, we would use several libraries and everything. And based on whether it is a real-time model, real-time inferencing model, or batch model, you want to make sure that it is packaged. You want to make sure that a cluster is created with the required libraries that is getting used by this particular model for training purposes. And that is what would happen in the pipeline continuous integration stage. Continuous delivery, you deploy the artifacts produced by the integration stage to the target environment, and output of this stage is a deployed pipeline with a new implementation of the model. So if a model is a batch model, it will go out and record the scoring to a batch table, where it is a model score table, which will have a model ID, a customer information if it is a customer, saying like, this is the model that was run and this is the score, this is the desired. All of those information are getting stored based on this continuous delivery output. Automated triggering. This is very important, and we talked about in the last point. Now everything is done. That is, after this pipeline continuous delivery, there is a stage that we put in where it will check whether the features are drifting. When we say features are drifting, for example, I'm having a feature which, sorry, was there a question? Okay, I'm having a feature, for example, you can say a feature which is sex, male and female, and that is how the model was trained for like 1 year or so. And I have another value that is coming into this sex feature, and there is a third variable, that third value that is coming in, and none of the model or none of the training is the scoring that was done was seeing this particular third value that is coming in this feature, and which means there is automatically a drift that is happening, feature drift is happening. And there are algorithms, or there are libraries that would take care of identifying how much is a PSI change. And based on that change, we will identify that whether a model needs to be retrained, because there is a huge impact that is coming because of this extra value that is coming in a feature. And that is what this automated triggering would happen. So in this case, on a daily basis, if the model is to be scored, now when we are scoring, the value that is coming out of feature is seeing a feature drift. what would happen is it will go out and trigger model training. Now, because I see that the feature is changed completely, and the existing scoring f of x equal to y formula is not going to work out good, and it's not going to decide the results that you're looking for. So I need to retrain the model, and that is what this automated triggering part would take care. And model continuous delivery, you serve the trained model as a prediction service for the predictions. The output of this stage is a deployed prediction service. Today, this is very, very important. If you take LLM or if you take normal models or anything, an API prediction service is really, really important for someone to call. And this is what you would do in ChatGPT or any other place, right? You call an API for giving API token, you would pass the value, and it will run against models, model file, whichever format it is in, and then it will get the output, whatever it is. It is a score, it is a classification model, then it is 0 or 1, whatever value that's going to come out of it, it's going to come out of that, and that is what is model continuous delivery. And finally, the monitoring, which I talked about again, you collect statistics on the model performance based on live data. The output of the stage is a trigger to execute the pipeline or to execute a new experiment cycle. So this is also something that you would see. The monitoring is one that would use the automated triggering to do whatever that we want to do. Now, coming to the next slide, right? So just talking about the maturity here, right? So I have to say, we started with this maturity level, whatever you're seeing here. We will just do an EDA, and there is offline data that is available. We just manually do the experimentation, looking at what data it is. We will do an EDA, we arrive at a feature, and then we do a model training, and then we evaluate it, validate it. Then we go to the training, and then finally go to the serving, and then do prediction services. Each and every layer over here is manually done, and that is what is manual process. Then comes the process of pipeline automation, right? The whole process that is over here, data validation, data preparation, model training, and evaluation, it's called experimentation. Now, various tools are available. We can go out and use that as a library, and that would take care of making sure of the models that you are developing, which particular model is the best model that is available, and that can be output of this, which can go into a source code that can be registered into a repository, which will be linked to one artifact or whatever is your deployment methodology, and then you go out and deploy the model. And one thing that you see different between this and this is feature store, which is a very good concept where, again, this is also something that we went and implemented it 2 years back, where there are 10 teams that are working on 10 different problem statements. And it can be, one can be like improving customer experience, one can be like identifying customer churn, another can be the reason for why customer is calling in. All of these models, most probably 60% of features that it is getting used by the model would be very, very common. And what would happen 2 years before, we would be writing separate code in each and every model for the same features that we are using across 3 different models. What would happen is sometimes the logic might be different between these 3 models. The business might not have given the correct inputs while they are discussing about a particular problem statement. They would give a different input, and during another discussion, they would have given different input. What would happen? The same feature which is used in 3 models would have 3 different definition, which means 3 different logic that is taken care. And think about calculating that feature at runtime from the data that is coming in into the system. You are unnecessarily calculating these 3 features 3 times. And the cost that is involved, whether you are using cloud or on-prem servers or whatever it is, the cost involved to calculate this. I'm talking about just one feature. But today, each and every company runs like 200 to 300 models, and there can be anywhere between 10,000 to 15,000 features that is used between 300 to 400 models. And 60% of those features are kind of repetitive or duplicate between all of these 3 models. You don't need to do that, and you need to create a feature store, which means you arrive at a place like a data mart, like a data product. You would arrive at a place called feature store, which is data product or data mart for ML models, which is where you would do all of your machine learning techniques to go out and create that feature. You would put all of your logic or coding in order to go out and use the feature in your model. So by that way, what would happen? All the 10 models that is getting developed for this customer experience issues or whatever it is, it will use the same logic, same feature across all the 10 models. That way, I mean, you can look at the benefits that you're going to get. You don't need to redevelop feature, which you're cutting time. You don't need to use cluster to build the feature on a daily basis, which is also cutting costs, right? And you have methodology and logic put in place, which is approved by business once. So all of these are benefits that you would get by introducing a feature store in the middle. And now there are, in the feature store, there can be batch feature and real-time feature. When I say batch feature, these are features that are calculated based on yesterday's data, or D-1 or D-2 or monthly or weekly features. And there are real-time stores also, real-time features that are coming in. If I'm looking into a website, if I click on a particular link, that is recorded as the last link that is clicked by Ganesh. And that goes in as a real-time feature for us to go out and use it in a model to predict what is the next item that Ganesh would go out and buy in the website. So that would have an online feature store, and that particular feature now can be again consumed by 10 people. And if you don't have a feature store put in place, we are going to do all of those repetitive tasks again. So this is what would happen in a semi, I would say this as a level 2 as a semi-automated method to do it. And now all of this together is where you would have a fully automation pipeline. I have a better slide to talk about in this place, and this is what it is, right? And so connecting all the dots together, I would say this is kind of encapsulates on all the things that we can do in an ML pipeline, starting with business problem / goal definition. I would say from 1 to 9, we follow this as an MLOps process, just not only the model deployment, but 1 to 9. Business problem and goal definition of the use case. And then from there, identifying an AML solution or model identification of which model to go out and use to solve the problem. Then comes the part of, for this particular use case, which particular data from which database we would use. And if it is done, how do we prepare the data for to be consumed by the feature engineering layer? And then that is what would happen in feature engineering. And I talked about feature factory over here, which is nothing but a feature store. You can call it a feature factory, feature store, feature shop, whatever it is. But this feature engineering gets the data from data products, data marts and everything, and cooks a feature, which is like transpose. It'll be huge so that it is easy for the model development to use. And we record that information into feature factory. And from there is where the model development and training would use and develop the model. Then from there, it will go to the model validation evaluation. From there, it goes to model deployment. When the model deployment is done, it will go to model serving, whether it is batch or real time. And when that is done, it will go to model monitoring and maintenance. And that's the part where the continuous learning comes into picture. We should also be looking at if it is served. Okay, so this is where the versioning live traffic control is also taken care, right? So we do the A/B testing to look at, okay, now you use the model with you give the customers without model and with model and see it is really performing well, and then you switch the traffic based on that. You'll also get the feedback loop. Feedback loop is nothing but how good is the model predicting what the customers is looking for, and if the customer is really interested in what it is showing based on the model's prediction. And if it is not the case, how do we supply that information back to the model so it just gets retrained based on that? And that is what you would look in a perfect MLOps lifecycle. And all of these layers are kind of connected together with various bells and whistles that we can go and use. Now, what I have over here is I have called out on various things that is happening. I have given this slide as an information of what are the tools that are presently available in the market. And I would have to say that we have looked at all of those tools. There are cases where we are using some of the things that I have listed here. It can be a open source, it can be a home built, but these are some of the things that are available today, either as an open source or a buy-based mechanism. You can go out and, at least for the sake of understanding what it does, is where all of these are mentioned here. Starting with, if I have to go out and understand model diagnostics, how do I go out and validate the model? There are various things like label box, scale, nucleus, and aquarium that we can go out and use. Workflow manager is nothing but the one. This is the place where the automation, pipeline automation is done. You either use Airflow, you can use, I mean, there are so many things. Tecton, Kubeflow, anything can be, anything that is DAG based, you can go out and use that. Future Store, you can have a look at Tecton, which is a company that came out of Uber. The guys who came out of Uber started this whole feature engineering based company called Tecton, and they concentrate only on feature engineering. There is this Google Feast that you can use. There is Databricks, which is another company which also has feature store kind of software that is available that we can go out and use. Some other, I'm not going to concentrate too much on a machine learning platform. I think this is very important. This is the workbench that people got and use. This is very, very important because so many things are enabled today using this platform, right? Collaboration has to happen. Monitoring has to happen from the leaders who is taking care of this use case. They don't need to disturb the developers all the time to understand what is the status. So there are dashboards that are available. So you can use Domino, you can use SageMaker, you can use H2O, you can use Collab, and you can go out and use Vertex AI, which is Google's platform that is available. This allows like people to collaborate. You can even link to Jira, you can link to Confluence. All of those can happen. So Workbench, this particular machine learning platform is really, really important so that it starts the guiding role for them to collaborate together. And some of the other things over here, I think you have to look at model registry. This is very, very important, right? So whatever model that I talked about, where when we know that the model is approved by the governance team, what we first do is make sure that these models are registered into model registry that has the information of what use case it is used for, who is the model owner, who is the data scientist, what is the performance of the model when they built the model first, and on a daily basis, the operational metrics of whether it has been scored, whether you have the drift happening in the model. All of those information are something that they kind of store in model registry. And auditing is another part that we can look at, where you can go ahead and use Credo and Armilla for that. Experiment tracking, this is the one that I was talking about, where you can use weights and bias. We can use MLflow, we can use Comet, we can use ClearML. I think MLflow is something which is open source that you can go and try easily. Maybe Comet also. And this is the one that will help you in experiment tracking. You're working on one use case and you want to just go out and try that out with various algorithms with a different hyperparameter tuning. You can just go out and use that to have the tool say which is the better model to go out and use it in production. And finally, monitoring. This is also very, very important. I talked about there are tools like Arise, Fiddler, Arthur, Truera, YLabs, and Gantry that you can go out and try. I think other than this, I don't have anything that I mean, I don't have anything to talk over here, but the whole idea is, again, if I look at the final line I have talked about here, and again, this is 1.5 years back, right? We should not be too much focused on tools that we want to use, but it's about the culture practice that these tools should enable, rather than making sure that it is not the UI, it's not the experience, but the culture and practice. When I say culture and practice, we should have the culture of collaborating. We should have the culture of making sure that we are following the governance process in place. We follow the process where we register the use case in registry and make sure that all the steps are followed. We are following the process of registering the features in feature store so that the features are reused by some other data scientists. Because if you don't do that, automatically they are going to create it again. And automatically there's going to be too much of operational cost involved in running those features. So I would say it is culture, practice, and tools together that would help us in enabling the whole MLOps process in order to get the things working better. And for sure, when you have all of this in place, you would get the benefits that you're looking for, which is efficiency, scalability, and also responsible AI. I think that's all I had to cover today. I know that it has been a long conversation. I just want to open up for any questions that you guys have. So I would see if I will be able to answer, and then if not, based on inputs, I can answer later also.
Okay, yeah. Thank you, sir, for the way you have explained the operations. How does it work in the background? We definitely get to know that what is this life cycle of ML engineering and what are the parts that each job role in the team definitely looks work upon.
Yeah.
Like before going with the Q&A, I would like to ask the question like as a let's say we as a new freshers will be initiating our careers in the machine learning. So maybe as a data analyst or business analyst. So what are the things we should look ahead in the future to work in this whole culture to become a better ML engineers, and what are the things one should work on? Like I have seen that there are ML models which are like traditional ML models, like we have regression and all. But we have seen that models are not restricted to the traditional models, but one can also take in the mathematical models. So what are the things one need to explore while entering in the field, and what are the guidance you would
Okay.
like to
Right.
give us?
So you're asking this question to an ML engineering person rather than a data scientist, right?
Exactly, sir.
For me, right, algorithm is algorithm. As I talked about, it is just an ML code that is sitting in between, right? But again, I'm not talking about a research project or anything. I'm talking about a ML application that is solving day-to-day customer applications, right? For me, we have to make sure that you're not calling yourself as a data scientist, but a full stack ML engineer. Because today, a full stack ML engineer would know data science, would know DevOps, would know data engineering skills together, which is something that I don't I see lacking, where data scientists concentrate too much of only model development, but lose on data engineering and on DevOps process following, where when you automatically look at data engineering, most of the data preparation side, you're not dependent on someone else to do the work for you, and you'd be able to look at what you can do better to prepare the data for the problem that you're trying to solve. So I would say that we should be a very good data engineer, a very good DevOps engineer, and also I mean technically good data scientist, which means you're very strong on algorithms. That is what I would expect, right? I'm not too much worried about how you're going to do the code, but you're technically strong on how the output is, how the output that you're getting is solving with what you're seeing on the problem statement. I would answer that as the three things to look at. Did I answer it, Utkarsh?
Uh, yes, sir. It answered.
Okay.
So continuing to this question, we have a question from our audience is that where do you apply these models in terms or AWS or Azure Web Service? Like how do
So
the
when you say
implication
deploy, right?
happens?
Yeah, right. So AWS or Azure, they have their own. AWS, it is very clear, right? So they have clusters, they have Kubernetes clusters that are available today. So we have both AWS and also GCP that are available. So based on model type, based on the library it uses, we create clusters with the libraries that are used, and we go out and deploy it in AWS. In case of GCP, we have GKE, and what we do is we create ephemeral clusters. That means it would just take the resources that it is needing, and then based on that, it gets deployed in GKE, and there will be an inferencing layer created in GCP, so that we go out and have that inferenced wherever that we want to use.
Right. So this should answer the question asked by the Harishankar. Another question we have from audience is from Brijesh Kumar. Is that do you suggest that this level of MLOps for startup or business that just started, or like in case of workforce and money constraint,
No,
or
absolutely
is there
right.
any other?
Yeah, absolutely. Workforce or money constraints should not come in between this MLOps process, right? Irrespective of whether it is a startup or a business. I mean, if you would have heard, right, 60 to 80% doesn't go to production. But I'm not saying you should follow it on day one, right? When we know that you have a problem statement, you might be just working as a single person in the company. You just go out and build the model, and you know that everything is good. The next thing that you would know that when everything is good is there is going to be more and more change coming to that particular model based on the business logic change, based on the customer who's asking, based on things that you're going to see as change in the data. And when you have put something in market, the customers are going to have that response immediate. And at that time, if you're going to take the same time in order to get the output, they're not going to wait for it. And that is where this MLOps process comes in place, and then it helps you a lot. So irrespective of startup or business, maybe for startup, you can say it is cost constrained, you just run it on a local model, but you need to go cloud or hybrid cloud. But at that time, after your first build, you should start following the MLOps process to put it in structure so you're able to deliver things faster. That is what we have to do.
Understood, sir. Continuing to this again, like we have another question from audience is
Yeah.
that is the regular model update cost effective? And how do you minimize the cost, like in terms of like deploying and stuff?
Absolutely right. Very good question here, right? The model update, when you say, I would understand it's a model retraining that we are talking about here. The model update means it is model retraining, and the model retraining doesn't happen just blindly, right? It happens because you see a change in business because of which the model is not scoring properly, and the output that you are saying to the business is not right, which means you're also losing money on the marketing side because you're giving a wrong prediction. So if you equate the cost, because when you're putting a model in production, it means that they have already done the KPI to say that, hey, you have put a model in production. I see that I'm benefiting huge. For example, your Axary recommendation model that I have for a phone in a Flipkart. And because of that Axary recommendation, I'm really getting like 2 or 3 extra sale on a hourly basis, which is increasing my revenue by maybe 10 crores or 20 crores in a month. And all of a sudden, I see that revenue going down to 15 or 10 crores from 20 crores, and it is because of the prediction that is going wrong. Will you equate the cost, or will you equate the revenue that you're losing? For sure, the cost that you're going to incur in training the model is going to be penny considering the revenue that you're going to get out of it. And that is what that is how you decide on whether it is cost effective to train the model. And also, you have a lot of algorithm that is put in place that would decide if you want to go out and retrain the model based on a particular value. You use PSI or whatever that is available in the library. You can use that to decide, hey, really is a model retrain needed? Will I be able to get better benefit or better scoring or better output than the existing model that I see? So that would decide whether you want to retrain every other day. And the retrain will not happen every other day. It will just happen a month or 6 months once, based on business logic change or data change.
Understood, sir. Yeah, that should really explain.
Yeah, right.
Okay.
So going back to, I saw that, do you suggest this level of MLOps for startup? I think I answered that. Yeah, I'm going to provide the PDF version of it. LinkedIn profile of Sir, it's Ganesh Siddhamalli. You can search for Ganesh Siddhamalli in LinkedIn. What level student can understand this session completely? That is where I'm coming, right? I know, I'm thinking everyone over here is doing BS data science. Is that correct? Or
Yes, sir.
sorry, BS is it BS computer science, or what is the
It's a
subject?
data science. It's a
It is data
BSL
science.
data science. Yeah.
For some reason, it is saying CS, which is not true, which is not right. Sorry about that. So When we are saying BS data science, for sure, by end of 4 years, knowing this now itself, and you coming out of this and you talking about this in front of the company that you're going to go, or the course that you're going to do after BS, noted now, guys, concentrating on this, drilling down on each and every layer that you're seeing over here, you just come back and say, thank you, Ganesh, for sure. Okay. And we learned it the hard way. I'm still trying to make sure the employees over here are understanding each and every concept over here, understanding how much of a benefit it is going to bring for the developers here to know end to end. And that is one way also to make sure that as a data science, sometimes what would happen? You guys just only concentrate on 5 and 6. And following the Mlops process, you would know from end to end on what is happening. And this is really, really important, at least in this world now. Okay. And it doesn't matter what type of course you are in. It is always good to learn about it now itself. That is what I would say. Okay.
Yeah. Yes, sir. Thank you for the
what is
great
the
guidance.
most challenging part of ML? I mean, when you say most challenging part of ML, I would say the data preparation and feature engineering team. Some might not accept it and they may say algorithms, but irrespective of algorithms, irrespective of whether it is auto ML or you guys writing your own algorithm to do a model, if the data is not good, if the feature engineering is not good, you're not going to get the results that you're looking for. And preparing the data, knowing the domain, guys, that is very, very important. That is also something that people don't worry about. You need to know the domain, and that's the only way. You need to learn the, if you're given a problem statement, the first thing that you should do is not jump into doing the algorithm, doing the data, but understand the whole system, understand how the customer uses it, understand the pain points that you would see. I would say doing that step itself will lead to identifying what features, what data to go out and use in predicting the outcome. Okay. That is what I would say as the most challenging part of ML. Which cloud platform can we use to deploy our ML models? Like, which is the best? I would say maybe because we are using GCP, I would say GCP. But again, guys, for all the students, you would have Azure available, you would have GCP available, you would have AWS available. All the 3 models are available today for you guys to go out and train a model and then deploy a model. So it's based on how much of a user experience that you're looking for, how much of a good workbench that you're looking for. I would say if it is a good workbench and everything, you can go to Azure, but ease of use and everything, I would go to GCP also. But maybe AWS SageMaker, I've not used it for the last 1.5 years or 2 years. I'm not sure. Maybe this makes me to think which is better. For me, I would rank like GCP, Azure, and AWS SageMaker. How can we include these tools and practices in our study? Sorry, was there a question, guys? Sorry.
Yeah, that's the next question.
Okay. How can we include these tools and practices in our studies now, right? So this slide over here, you don't need to do anything. Just pick up a tool over here, understand what it does. If you just search for it, it would say what it does. And then you can just finally connect all the dots together. That is what you can do. And or given a use case, like for example, you'd be doing a use case in your BS data science. You can see how do you go out and do this in your use case, and you don't need to worry about anything. You can just go out and use MLflow. Most of these are like feature engineering, model development training, model deployment, registry, and most probably monitoring. All of this are available in MLflow also. That is one tool that has everything together. I would even say go out and try to start using MLflow for your next use case of model development. It has Jupyter and everything. You can go out and do that. Or H2O is another tool that you can go out and use. You have cloud-based H2O that is available, which is free for students. So you go out and do that. You go out and name it saying, this is what I do. Or when you're preparing a document or when you're preparing your business case, you go out and name it saying, this is a business problem. This is the goal definition. Goal definition is very, very important, guys, right? So you need to understand what is the problem statement. You need to also say over there, what is the outcome that you're looking for? how are you going to solve the problem statement, and what would the business benefit by introducing this model. Most of the models that is getting developed today, we just go out and develop it, but there are businesses that don't know how to use the model into the business case, right? That is one thing that you need to solve in business problem and goal definition itself. If I'm going to give a particular model, you need to know how the business is going to use that in order to benefit from it. And what I would say is create documentation first to start with, saying what we would do in each and every layer of this. I think that would easily prepare you, kind of coach you going to the next level. And I mean, following this for each and every model development that you're going to do in your whole BS data science would just prepare you a very good ML engineer. I have sent connection requests. Absolutely, guys. Send your connection request and I will just go ahead and accept it. And I would love to learn. You can message me for any challenges that you're facing or any other things that you can do. We'll go ahead and do that. Can we train a voice large language model like Jarvis from Iron Man someday? Like, what would be the cost of it? Is it possible? Absolutely, guys, right? So I'm not talking about a base model development here, which I'm not capable of, but there are LLM studios that are available from Google, from H2 and other places, where either you can link to the existing models, LLM models that are available, or you can create your fine-tune the model based on whatever you want to do. And that is available today in H2O and also in Google. So you can go out and look at that and see how you want to go out and use it. I think I answered how can we include these tools, practices? Can we train a voice language? Answer that. Absolutely. I think this is what I see, guys. So if there is anything, you can ping me anytime. I know that someone has also talked about one-way communication going on. I would, sorry about that, Jeet. I'm not sure if it is a muted one. Maybe that's an input for me. I would watch to it and maybe ask questions in the middle if you want to go out and cover it. Do that. Okay, I think I've answered everything over here, guys.
Yes, sir. Yeah, you have answered all the thing. Regarding more regarding PDF, the about the PDF.
Absolutely. I will create the PDF and send it across to
Sure,
Jayesh,
sir.
and from there
Yes,
should
sure, sir. That should work. We'll share accordingly to the student body.
Absolutely.
And yes, sir, regarding that one-to-one conversation, it was a great session, first of all, nothing to be there. That's how we should get to know what is the whole process is there. Then we should answer according to our
Absolutely.
needs. So yeah, it was a really, really great session and to interact. Looking forward to interact more. And we'll be definitely pinging you regarding the problems
Absolutely,
we'll
guys.
be thinking in the near future while developing. So
Thank you.
right now, yeah, we can wrap up the session. Thank you for giving us your time, and I thank the audience for here to attend the session. Thank you, everyone.
Thank you, everyone. Thanks. Bye.
Thank you, sir.
Thank you.
My sir, we can end the session.